Hi, boys and girls. Now we're going to look at the math for the packet this week. This math is all about equivalent fractions. We've already been working on equivalent fractions for the last few weeks, but this week is a little different because now instead of using multiplication to find equivalent fractions, we're going to be using division. So instead of splitting up our diagrams, we're going to be drawing circles and grouping things together. So it's the same basic concept, just doing the opposite or the inverse operation. Okay, let's look at that on the first page. So they've done the first one for us. We started with 2 4s shaded, and then we can divide both of those by 2. So we're looking for a common factor, a number that divides evenly into both numbers. And 2 is divisible by 2, and so is 4. So we can divide them both by 2, which gives me the equivalent fraction of 1/2. And then I can also show that by circling 2 groups, and 1 out of the 2 is shaded, which shows me that it is equivalent to 1/2. Let's do B together. So here I start with a fraction of 1, 2, 3 that are shaded out of 4, 5, 6 all together. So I have 3 6 there. Now I'm going to divide both the top and the bottom numbers. What can I divide them both by? Well, I can divide them both by 3. 3 goes into 3 one time, and 3 goes into 6 two times. So I see that 3 6 is equivalent to 1/2. And I can show that on my diagram by just circling. I have 2 equal groups of 3, and 1/2 is shaded. It's also like if I imagine these lines going horizontally are not there, that would also show me 1/2. Okay, let's do one more of these. We're going to skip down and do F just because it has more boxes, but all of these will be done the same way. So here I have 1, 2, 3, 4, 5, 6, 7 shaded. And I have 14 all together if I count all of those. So I have 7/14. And I think about what number I can divide both of those by. Well, I can divide them both by 7. 7 goes into 7 one time, and 7 goes into 14 two times. So again, it's equivalent to 1/2. We're going to see a pattern there with that. And I can circle my groups that show me that I have 1/2 out of my total that's shaded. Okay, you'll do the same thing with C, D, and E. The next page also is the same thing. So I'm going to count how many I have. I have 2 6 here. 2 6, they're shaded. I'm going to divide the top and the bottom. And I think about what can go into both 2 and 6. Well, 2 can, so I'm going to divide both by 2. 2 goes into 2 one time, and 2 goes into 6 3 times. So now I have 2 6 is equivalent to 1/3. And I can circle. I'm going to have 3 equal groups since this is 1/3. And one of my 3 groups is shaded. So I do that same thing for B, C, and D. Down here it asks me some questions about how my fraction changes when I go from 2 6 to 1/3. What happens to the size of the fractional units when you compose the fractions? So before I had 6 pieces, now I only have 3. So what happens to the size of my pieces? If I pretend this line is not there, my pieces get larger than they were before when I composed them. What happens to the total number of units in the whole when you compose the fraction? So instead of having 6 units, I now have 3 units. So there are less units or less pieces, and the pieces get larger. Okay? The next page is very similar. Now it wants me to, in the first area model, show 2 6, and they've kind of already done this for me, but I'm going to do it anyway. So I'm going to have 6 pieces, and 2 of them are shaded. Okay, that gives me 2/6. In the second area model, show 3/9. So now I'm going to break it into 9 pieces, and 3 are shaded. Okay, so I've done that part. Show how both fractions can be renamed as the same unit fraction. Part of the first one has been done for you. So again, they kind of did the first one here. So I circle groups, equal groups. So that shows me that 2/6 is equal to 1/3. And I can do the same thing here, circling equal groups of 3. This shows me that 3/9 is also equal to 1/3. Down here it wants me to model it using division. So I'm going to take 2/6 and 3/9 and I'm going to divide them to show that they are equal to 1/3. So what can I divide 2/6 by? Well, I can divide them both by 2. 2 goes into 2 one time. 2 goes into 6 3 times. That shows me it equals 1/3. And here, well, 2 doesn't go into it, but 3 does. 3 divided by 3 is 1. 3 divided by 9 is 3. So that shows me that 3/9 and 2/6 are both equal to 1/3 using division. Okay, you're going to do the same thing down here. You're going to draw 2/8 here and then 3/12 here, and then circle the groups to show that they're equal, just like we did up here. And down below, you're going to use division to show how 2/8 and 3/12 can be equal, just like we did on part B right here. This next page is exactly the same as the other one, drawing, circling the groups, and then writing the division sentences. And this lesson 10 problem set is exactly like what we did on the first couple pages. We'll do one together if you need a refresher. If not, you can definitely skip ahead in the video. But they've already done this one for you. You look at the original fraction you start with. Here we have 3, 6, 9, 12. So 9 are shaded out of 12 altogether. Then I do my division. What number goes into both 9 and 12? Well, I can divide both of them by 3. 3 goes into 9 3 times. 3 goes into 12 4 times, so it is equal to 3/4. I can also draw that by circling. Okay, 3 groups out of 4 are shaded. They're all equal groups. Okay. All of these are the same way. Now let's look at the next page on the lesson 10 problem set. Here it says to draw an area model to represent each number sentence below. The first one has been partially started. Okay, so we start with 4/10. They've already drawn that for us. And then we can divide them both by 2, which gives us 2/5. We just need to circle the groups on this one. Okay, 2 groups out of 5 are shaded. Now we're going to do the same thing here. I'm going to draw my rectangle. I need to show 6/9, so I need to break it up. Ooh, my pieces were not equal. Let's try again. All right, and I'm shading in 6 of them to have 6/9. Okay, so now I have 6/9. And they've already done the division for me. I can divide both of them by 3 to get 2/3. So all I need to do is circle my groups. 2 shaded groups, 1 group that's not shaded, 3 groups altogether. Okay. Down here, we need to use division to rename each fraction given below. Draw a model if that helps you. See if you can use the largest common factor. Okay, so we want to think of the largest number that divides into the top and bottom both. We do not need to draw a picture on these ones. However, if that helps you, you are more than welcome to. I'm just going to demonstrate using the division, but again, if you want to draw pictures like we did up here, you can do that. So I'm thinking of the largest number that divides into both 4 and 8 evenly. That's going to be 4. 4 goes into 4 one time, and 4 goes into 8 two times. So that equals 1/2. And that's all you need to do on these ones. Thinking of the biggest number that goes into it and dividing to find the equivalent fraction. Okay, on this lesson 10 homework page, I am not going to demonstrate it again because it's the same exact thing we just did on like 3 different pages. You write what the original fraction is, you divide it, and then you circle the groups. This lesson 10 homework is also like the other page we just did. You're going to draw the original fraction, and then you're going to circle the groups to make the new fraction. So I'll draw 6/15, then I'm going to circle groups so that I have 5 groups and 2 are shaded. Same thing for part B. Let's look at 12. Choose one of the fractions to draw an area model. Then compose your area model to show larger fractional units. Express your equivalent fractions as a number sentence. Okay, so I just need to choose one of these fractions to draw an area model of. So let's do 6/9. And you can choose any of these. I just happen to choose 6/9. So I'm going to draw my area model. And I'm going to create 6/9. Shading in 6. Okay, there is 6/9. And now I need to compose it to find larger units. So I can just circle my larger groups. That shows me that this is going to be equal to 2/3. I can also show that by dividing. 3 goes into each of them. 3 goes into 6 2 times. 3 goes into 9 3 times. That shows me it equals 2/3. And my model was correct. Okay, this is our last page for this week's math. This one is also just like another page we did. You're going to use division to rename each fraction. Draw a model if that helps you. So again, on this page, you don't need to draw the model unless you want to. You are just thinking of the biggest number that goes into both the top and the bottom. So the biggest number that I can think of that goes into both is 6. 6 goes into 6 one time, and 6 goes into 12 two times. So it is equivalent to 1/2. You'll do the rest of that page the same way. And that is it for this week's math. Hopefully that was helpful to you. Hopefully I didn't go too fast. You can always go back and re-watch any parts of the video if you need to help you do those extra problems if you forget how to do something. I hope that you have a great week. Thank you for taking the time to watch this, and I will be in touch with you more next week. I look forward to hearing from you and hope you are well. Bye.